Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to determine if a function is even or odd. So first, I guess we should say, what are even and odd functions in the first place? So first, even functions, there's three things I want you to know. Number one, even functions have y-axis symmetry. So to give you an example of a function that has y-axis symmetry, the easiest example would be y equals x squared, the parabola, because it just looks like that. And as you can see, it's symmetrical along the y-axis. So 1, even functions have y-axis symmetry. 2, this is what y-axis symmetry looks like. And the third thing you need to know about all even functions, and this is the important one, what we're going to be spending most of today talking about. If you have some function f of x, and it's an even function, then that means it is equal to f of negative x. And this is the confusing part. I'm going to explain it better as we go on today. But what this means, just quickly, if I replace all my x's with a negative x instead, I'm going to get the exact same function. So as a quick example, I said this was x squared. So if I write x squared and then f of negative x, which is replacing all of my x's with a negative x, and that's still squared, isn't any negative number squared a positive number? The answer is yes. And because of that fact, x squared equals x squared. Check. So in other words, yes, this is an even function. So that's it for even functions. Now odd functions. So if you're a perceptive individual and we said that even functions have y-axis symmetry, then it makes sense that odd functions have x-axis symmetry. But of course that's not true. That would make too much sense. And math isn't about making sense. It's about memorizing a million useless rules. We say that odd functions have origin symmetry. What the heck is origin symmetry? I will tell you. Origin symmetry is where if you flip it along both the x and the y axis, like a reflection, you are going to get the same function. As an example, here is the function y equals x cubed, or at least close enough to it. And so it doesn't matter if I want to flip it along the x-axis or the y-axis first. I'll choose the x-axis. If I flip it along the x-axis, it will look like this blue line. Okay. And then if I flip it from here along the y-axis, it is going to look like this. And as you can see, it perfectly falls along the red line. If you don't see how I did this or you're still confused, that's okay. I think it's just going to take some time for you to fully understand this origin symmetry concept. But regardless, the important thing is the third thing, that all odd functions have the following property. F of negative x is equal to negative f of x. Or if you prefer, f of x is equal to negative f of negative x. That's another way you can write it. I usually don't like the second way because I think it's a little confusing. I like the first way. And so that's the version I'm going to be using today. Now, just as an example to prove that this works, with x cubed, if I replace x with negative x, it's going to look like this, negative x cubed. And then I want to know, does this equal negative f of x? In other words, just putting a negative sign in front of x cubed looks like this. You'll notice there's no parentheses. There's a very good reason for that. That's because if I were to put parentheses, they'd have to go here around the entire x cubed versus the left one, which is just putting the parentheses around the negative x. That's the big difference between f of negative x and negative f of x. Hopefully you see that. Anyways, if I were to simplify negative x cubed, I don't know if you know this rule, but if it's an even power, it becomes positive. If it's an odd power, it stays negative. In other words, this is negative x cubed. And the right one is going to be negative x cubed automatically because of the placement of the negative sign in the parentheses. And because these are equal to each other, it gets the check mark. This is an odd function. Now, one final question for you. Can you think of a function that's both even and odd? Go ahead, take a minute. I want you to think about this. There's only one function who is both even and odd, and that is the function y equals 0. So everything else, every other function in the universe is either even, odd, or, don't forget the third case, you can be neither. It is very easy to be neither even nor odd. And the only function that can be both is 0, and for that reason you usually don't see that example show up on the test or the homework unless they're trying to trick you, just so you know. So then now for the rest of this video, we're going to be looking at some example problems, and you are going to be telling me whether the function is even or odd. And I'm going to show you a shortcut in about 2 minutes about how you can determine the answer with hardly thinking at all. So for the first example I have f of x equals 2x squared minus 3x plus 4. And I want to know, is this function even, odd, or neither? So I'm going to do this first one with you. It's always a good idea to check for even first, and I'll explain why in a minute. But to do the even check, all you got to do is find f of negative x, which looks like this. 2 times quantity negative x squared minus 3 times negative x plus 4. So here, negative x squared, because it's an even power, it becomes positive. So it's positive 2x squared. The negative 3 times negative x will become plus 3x, and the plus 4 stays as plus 4. Now the question is, does f of negative x equal f of x? Because if it is equal, then it's even. If not, then it's not even. It might not be odd, it still could be neither, but it's not even if they don't match. And they don't match, because look at this positive 3x and this negative 3x. It does not match. So in other words, all we can write right now is that the function is not even. Now we still have to check for odd. Now earlier I mentioned it's always a good idea to check for even before odd. The reason why is because if you want to check for odd, remember you're starting with f of negative x. In other words, it's kind of impossible to check for odd function first, because in the process of finding odd, you already need even, the even check first. So anyways, we already did the f of negative x. We already said that's 2x squared plus 3x plus 4. Now for negative f of x, watch how I do this. I'm putting a negative sign here, and then the rest of it goes in parentheses. So like the original function, 2x squared minus 3x plus 4. I just have to distribute the negative sign to every term. It's going to be negative 2x squared plus 3x minus 4. And the question is, does this equal 2x squared plus 3x plus 4? And the answer is obviously not. So we would say it's not odd. And since it's not odd and it's not even either, then there's only one option it can be, and that is neither even nor odd, which is perfectly fine. All that means is the function does not have y-axis or origin symmetry. And in case you're curious, we didn't mention x-axis symmetry because no function has x-axis symmetry. The only example of a function with x-axis symmetry is one that looks like this. And this breaks the law of functions because it doesn't pass the vertical line test. In other words, every input has more than one output. And in case you don't know what I'm saying by that, just trust me when I say we will never have a function that has x-axis symmetry. Okay, now let's do another one. Number 2. I have y equals x to the 5th plus 8x. So go ahead, maybe you should try this one on your own and tell me if it's even, odd, or neither. And when you're ready to see the solution, unpause the video. Okay, so the first thing I'm checking for is even. For the even check, I am finding f of negative x, and even though this is y and not f of x, it's the same idea. I'm just replacing every x with a negative x, like this, and then I have to simplify it. Remember, odd power, 5th power, stays negative. Negative x to the 5th, and then positive 8 times negative x is going to be minus 8x. And so then the question is, does this equal the original x to the 5th plus 8x? Obviously it does not, so it is not even. So then now I check for odd. To check for odd, I need to check negative f of x. That's where I put the negative sign in front of the whole thing, and then I distribute the negative sign to all the terms. So that's going to be negative x to the 5th minus 8x. And does this negative f of x equal f of negative x from earlier? And the answer is yes, they are an exact match, which means that this function was odd, and it does have origin symmetry, if the question asked for that. Now, as promised, there is a shortcut to finding if a function's even or odd. I will now tell you that shortcut. If a function is even, then all of the exponents in that function have to be even. In other words, if I have x to the 6th minus 2x to the 4th plus 3x squared, since all of the exponents 6, 4, and 2 are even, this is going to be an even function automatically. I don't know if your teacher will accept that as your work, because again, this is a shortcut. But if your teacher says this is okay, then all I would write is all the exponents are even, we're good, it's an even function. And then you guessed it, if we have an odd function, then all of the exponents must be odd. The coefficients don't matter at all. All that matters is the exponents. And remember that if you just have an x, there is an invisible first power here, which is why this is odd. Now here's a challenge question for you. If I have f of x equals x cubed plus 1, and I use the shortcut method, is this even or odd? And the correct answer is, it is neither. I know the x cubed is odd, but if you ever have a constant like plus 1 or plus 50 or minus 22 or any constant, constants are always even. The reason why this is technically x to the 0, because anything to the 0 power is just 1, so it kind of disappears, and 0 is an even number. So in other words, going back to my previous example with this x to the 6th minus 2x to the 4th plus 3x squared, if I put a 15 out in front, 15 is a constant. I don't care that it's an odd number, that doesn't matter. Just the fact that it's a constant means it still fits in the even family. So in other words, the answer to this one, x cubed plus 1, the answer is it's neither, because it breaks the rules of both even and odd. So that's the shortcut method. You can even try the first two that we did today and see that they both follow the even and odd rules that I just said. And if your teacher doesn't want you using the shortcut method, that's fine. You can still use it to check your answer very easily. Now, the final thing I want to talk about in this video, if you have a rational function, that's the ones that look like this. If you have a rational function, then I would not recommend using the shortcut rules, and here's why. According to the shortcut rules, this has both x squared and x cubed in it, so it's neither. It's not even, and it's not odd. However, that's not right. If I solve this problem the normal way, which is first finding f of negative x to check if it's even, then I'd get negative x squared plus 1 divided by negative x cubed. That would reduce to a positive x squared here plus 1 divided by a negative x cubed. Now obviously these do not equal each other. In other words, it's not even, and that much is still true. However, when I check for odd and I look at negative f of x, well then it's going to be negative quantity x squared plus 1 divided by x cubed. And maybe you say, oh, these are not equal to each other. You are wrong, because this negative sign in front of the x cubed can be pulled out in front of the whole fraction. Negative signs are the only symbols that are allowed to do that in rational functions. So in other words, what I'm saying is f of negative x is equal to the same thing as negative f of x, as you can see here. So in other words, this function is odd, even though it doesn't follow our shortcut rules. And so maybe if you're really smart, you can come up with your own set of shortcut rules for rational functions, and you can waste a lot of time and brain power doing that, but my recommendation is to just do it the normal way, and you'll get the right answer every time. So that is everything I have to say about this topic. If you have any questions, please post them in the comments. Thank you all for watching. Have a great rest of your day, and I'll see you in the next video. Take care, and bye-bye.